This is Greg from GitLab Support. In this video, I will go over how to manage and reduce CI minute usage on GitLab.com. I will start out by showing the user interface and user experience for visualizing CI minute usage. CI minutes are used per project, and the usage quota is at the namespace level. So that would be either at the user name level or the group level. Next, I'll summarize several options available for users looking to streamline or optimize GitLab CICD jobs and pipelines to help improve efficiency and reduce their CI minute usage. Last, I will show how to bring your own GitLab Runner and connect it to GitLab.com as an alternative to using shared runners. Only the GitLab.com provided shared runners count toward CI minute limits. So when using your own runner or runners on GitLab.com for GitLab CICD, CI minutes are virtually unlimited. The page I have pulled up in my browser here, this is the namespace view for my group. My group is called Just Greg, and it includes just me. Here I can see these are the different subgroups and projects I have in this namespace. To see my usage of CI minutes, I go to Settings and Usage Quotas. This pulls up a per project breakdown of CICD minutes. I can see here that overall, since August 1st, I have used 208 minutes in this namespace. And looking at the per project minute breakdown, it looks like this distance runner is taking up most of the CI minute consumption at this point. If I click on one of these projects, then it pulls up the project page. From here I can go to CICD. This is the pipeline view. This is a valuable source of information. Here I can see the time taken per job. So it looks like, per pipeline. It looks like this pipeline took 39 minutes, this one took 31, and this one took 31 as well. I can see I have a limit here of 2,000, so I can also click to buy additional minutes. I'm not going to go over the purchase flow in this video, just wanting to point out that that's where to go to get some extra minutes. Now that I know which projects are using my CI minutes and how many CI minutes each project is using thus far, I can think about how I could go about either optimizing or streamlining my GitLab CI/CD jobs and pipelines to improve efficiency and reduce my CI minute usage. One way to restrict your CI pipelines and jobs from executing only when you need them and if you need them is to use rules in your CI job. And somewhat intuitively, we use the syntax for workflow rules of if and when. Additionally, there are options for when manual. Manual is a good option if you only need to execute this job by manual intervention. This is a good way to avoid jobs that are costly in terms of CI minutes from executing on every push. If you use when manual, then you can define when you would like it to occur and specify that you would like it to occur after manual intervention. Otherwise, there are the rules, which also have if and when in the syntax. Combining the power of rules, workflow rules, when, we can pinpoint specifically at what time we would like to use CI minutes and ensure that it's only if we need to and when it's helpful. In the same vein, there is the risk of scheduling pipelines too frequently. This is not for scheduled pipelines. They are a bit different than a regular pipeline in that these pipelines are configured generally through the user interface, and they use cron syntax. And we can see here that this is something separate from the if-when rules and syntax for GitLab CI. This is in the user interface itself. For an example here, I can show you this runner here, aptly named Runner on a Schedule. This is set to run every 5 minutes. I have a pipeline that is scheduled. We can see, okay, yes, it is running every 5 minutes. Now, it's pretty rare that someone would need to run a pipeline every 5 minutes, so seeing no project activity last update 2 hours ago, I can deduce that this is a scheduled pipeline. And here it is. We have the per minute weather report pipeline. And this is cron syntax, but this says every 5 minutes execute this CI job. I'm going to change it from every 5 minutes to every day. Now, I will keep this tab open and we'll come back to it later, but I would expect that this no longer executes every 5 minutes, that it changed it to once a day. So in doing that, I've effectively reduced the number of jobs and therefore number of minutes that I'm using CI minutes on a shared runner. There is also Pipeline Schedules API endpoint. This is good for automating, either getting or editing, deleting, modifying pipeline schedules in a programmatic way. Another somewhat common way of eating up CI minutes is to have a job that has no timeout, or it has a long timeout, and that job is freezing or failing silently, and for whatever reason the job does not terminate. It always hits that timeout. On GitLab.com, our default timeout is 1 hour, but timeouts can be defined a few different ways. Timeouts can be configured per job. This per job level timeout can exceed the project level timeout. If instead of extending the timeout, I wanted to shorten the timeout, I could make the timeout on a job 30 minutes or 10 minutes. And this will also overwrite that 1 hour default. And this can be defined at the job level in the CI template. It can also be configured on the level of per project. Now, per job will override the per project timeout setting, but the per project timeout setting can be configured right in the user interface. Go to your project, settings, CICD, General Pipeline Settings. So let's find one that I think might be taking too long to time out. Think Marathon Runner. That sounds like it would take longer than a distance runner. Let's see. Oh, there's a job running right now. Test job. Wow. So this is a good example. This job has been running for 110 minutes, just under 2 hours, and it has a 3-hour timeout. I can fix this by adding a timeout. For the sake of demonstration, 1 minute to this. Now, I've not actually modified the job that's running. I've just added a 1 minute timeout. Now we see there's timeout of 1 minute coming from the job, and I would not expect this job to take longer than 1 minute, whereas the previous job was taking just under 2 hours and would have gone right up to that 3-hour timeout. Okay, job failed. Execution took longer than 1 minute. So for jobs where you want to have a safe check, make sure they're not just freezing and using all of your CI minutes. That is, adding a timeout can be very valuable. Go back to the beginning here. The last tip that I'll go over in this video for reducing CI minute usage on Shares Runner is to take advantage of GitLab Runner caching features. GitLab Runner has a caching mechanism that can be used to save time and CI minutes when running your job. Caching will speed up the time a job takes to execute by reusing content from a previous job. This can be particularly helpful for caching dependencies. We have this caching documentation here, which is comprehensive with good caching practices, common use cases, and we even have examples of CI templates demonstrating how you can cache your dependencies to reduce your build time. These are useful examples on how to cache dependencies for reuse in jobs so you're not constantly downloading. Another method to improve the efficiency of your GitLab CI/CD jobs and streamline the minutes you use is to use a Docker image that comes bundled with all that you need right off the bat, instead of starting with a base image and building up every time. To give an example of this, I have this CI demo job, and I have two different jobs within this job template. First is called From Scratch, and what this does is it starts with this image, it updates and upgrades the software that's currently installed, it downloads the software that I want to use, and then it executes the software to give me the results that I would like out of my CI job. This second example, this uses an image here that is essentially a snapshot taken of if you start out with this and go up to here and then pause. That's where this job starts. And therefore, the only thing that is required instead of these 4 steps is just 1 step. So let's see what that looks like in reality here. Going to run a pipeline. And I see here I have 2 jobs. One is all-in-one and one is from scratch. They're both running. And the timer has begun. I'll pause this and come back as soon as they have completed. Okay, so the jobs have completed. And we can see the all-in-one took 1 minute 39. And from scratch took 3 minutes 37 seconds. Now these jobs are relatively simple, but this could definitely be the same case with a much larger amount of time, where just installing the dependencies and software to get up and going in a job can take the majority of the CI minute time. Let's look at the difference in execution here. This is the job log. That's for the all-in-one, and this is for from scratch. Now, from scratch, we see it's a much longer job log. We're installing. It just keeps on going and going. 2,040 lines versus 248 lines. 1 minute 39 seconds versus 3 minutes 37 seconds. And that is done just by taking advantage of the container registry we have built into GitLab. I have this image here that contains all of those goodies, and here's the Docker file. It's extremely simple. This is just what I used to create that image, and that is what is in my GitLab container registry right here. Now, I mentioned that there is the option to bring your own GitLab Runner, which is essentially GitLab Runner software operating on a server or infrastructure that you control. Hook that up to your GitLab.com group or project and use that for virtually unlimited CI minutes. So I will demonstrate how to do that. In the documentation for this, so first, to get things started, we need to install GitLab Runner. Now, installing GitLab Runner means you have a server, a virtual machine, something running Docker, Kubernetes, OpenShift. You can even run it on macOS and Windows, FreeBSD. Some infrastructure on which to run the GitLab Runner software. And then we start from here. I personally like using Docker because I think it has some advantages over other types of runner. I know Kubernetes is going to be the best choice for auto DevOps and continuous deployment. Kubernetes runners are very powerful. And then there's also some situations where GitLab shell or just the package here, that's plenty sufficient or is preferable. I'm going to demonstrate how to do it using GitLab Runner in a Docker container. So to install GitLab Runner, this is pretty easy. I can copy and paste this command. And here's a terminal. I'm going to SSH into the server Greg Runner here. This is a server I'm using for this demo. It's a droplet on DigitalOcean, and it has Docker already installed. That's the only thing I did so far. So I just copy and paste this command into the terminal. I see this big number. That is actually a good sign. Because I can see here that GitLab Runner container is created 12 seconds ago, up for 11 seconds. And we have some logs coming in from that. Now, next step is to hook this up to my group or my project so that I can use this runner on GitLab.com. To do that, I register the runner. And requirements: first, you install the GitLab Runner, which we already have. And then we have the choice between project specific or group runner. I'm going to do group runner, and I select Docker from this menu here. To access the group runner settings, it's settings for my group, runners, and there's a drop down. See this heading, set up a group runner manually. So install GitLab Runner. That's the documentation I followed previously. Specify the following URL. Okay, that's easy enough. Here, run the register command. I can just copy and paste that. Now it's asking me for the URL. Asking me asking me for the registration token. A description, GitLab CI tags. These are very helpful most of the time. For demonstration purposes, I'm going to leave them out. I'll choose my Docker executor and default Docker image. Now it says runner registered successfully. And here we see I have a group runner. It's currently locked. That's my IP address. That's the description. If I click that, save. Now we see I have a dedicated runner for my group. Now I'm going to demonstrate running a job in my group using just that runner. Let's choose GitLab CI project. To specify, I don't want to use shared runners. I go in and I click disable shared runners for this project. Now that I have my shared runner or dedicated runner, BYO, bring your own runner, registered, let's see how I can actually use this in a project. So see, I have shared runners disabled. I could click enable if I want to, but nope. I just want to use my group runners. So it looks like this one is available. Let's try and see if we can run this job using my shared runner. And then in this case, it would not count toward any usage of shared runner consumption, CI minute consumption. I can see right here, this is my version of GitLab, and this is the description for this runner. So we can see right here, this is executing, and this will not count towards the CI usage as calculated in my usage quota here. To summarize, we started out by having a look at CI minute usage in the usage quota tab. We also took a look at some ways to reduce CI minutes and consumption of CI minute for shared runner, including rules in the job template to define if and when a pipeline should be triggered. We went over scheduled pipelines and making sure they're not scheduled to run too frequently. We touched on timeouts and how to prevent jobs from running longer than expected. We also touched on rules and caching and using caching to reload assets instead of download them fresh every time. And I demonstrated how having a Docker container with your dependencies in terms of software and executables built right in can reduce the execution time for your CI pipelines. And last, I demonstrated how to install your own GitLab Runner using the Docker executor, registered that runner on GitLab.com for a group, and then showed how to run a pipeline using that runner and no shared runners.